Welcome everyone. Today in this video, I Prem is going to tell you about conic section and what shapes we get after passing a straight plane to it through different angles. Before going to it, I would like to thank Priya ma'am, my maths teacher, for giving me the opportunity to experience the practical application of conic section through clay modeling. Let's start. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface is obtained is called a double right circular cone. A double right circular cone consists of two cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base, and its axis is always perpendicular line from the center of the base to the vertex. The perimeter of the base is called the directrix. The lateral surface of the circular cone is called a nap. A double right circular cone has a two naps. The nap above the vertex is called the upper nap, and the below the vertex is called the lower nap. Also, the angle between the generator and the axis is called the vertex angle. Conic sections. If a plane intersects a right circular cone, we get two-dimensional curves for different types. These curves are called conic sections. Depending on the angle made by plane with vertical axis of the cone, the plane can cut the cone in four different ways, that are circle, ellipse, parabola and hyperbola. Let's talk about them one by one. First angle, we are going to take a very flat plane which is at angle of 0 degrees. When we cut our cone using this, we get a right circular shape. As you can imagine very well that we are going to have a circle at every level in the cone. When beta is equal to 90 degree, this section is circle. A circle is the set of all points in the plane that are equidistant from a fixed point in the plane. The fixed point is called the center of the circle, and the distance from the center to a point on the circle is called the radius of the circle. Now I have increased the angle of my plane a little. Now when I cut my cone at this angle, my circle has a circular shape, doesn't remain anymore. It has trailed out of it to create an ellipse. When alpha is less than beta and beta is less than 90 degree, the section is an ellipse. An ellipse is the set of all points in a plane, the sum of whose distance from the two fixed points in the plane is constant. The two fixed points are called the foci of the ellipse. Now, in the third situation, I am going to increase the angle of my plane further, and I have reached at an angle such that this plane is now parallel to my cone. At this angle, when we cut the cone, the new shape that we are going to get is called a parabola. When beta is equal to alpha, the section is parabola. A parabola is the set of all points in a plane that are equidistant from a fixed line and a fixed point in the plane. The fixed line is called the directrix of the parabola and the fixed point F is called the focus. Para means for and the bola means throwing. That is the shape described when you throw a ball in the air. Now, in the fourth situation, I have increased the angle further. Even now, in this situation, when I cut my double cone, you can see that both my cones are now giving two independent shapes, and both of these together are called a hyperbola. When 0 is less than equal to beta and beta is less than alpha, the plane cuts through both the naps and the curves of its section is a hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distance from two fixed points in the plane is a constant. So what we saw here was we can get 4 different shapes by the same double cone when we cut it at 4 different angles, and that is why all these 4 shapes are collectively called the conic sections. I hope you like the presentation. Thank you.